Okay, this is the P3 paper from June 2023. It's question number 9. As you can see, this is a trigonometric question. There's some trig functions involving sec and cosec and cot. There's some trig addition formulae, double angle formulae, and there's a little bit of integration there as well. So lots of different topics to be looking at when we're doing this one. Let's have a look at the first part then, 9 part A, which is a proof. So we're starting off with part A, and it says we've got that cos 2x over sin x plus sin 2x over cos x, we need to show that that's equal to or identical to cosec x. So first of all, we're going to start with the left-hand side and make it equal to the right-hand side. If you remember that cosec x is 1 over sine, that's going to help me because basically these are the two things I'm going to be able to change. It's cos 2x and sine 2x. I always like sine 2x because I've got a choice. Sine 2x is 2 sine x cos x. But when I've got cos 2x, I've got a choice of cos squared minus sine squared, 1 minus 2 sine squared, or 2 cos squared minus 1. Well, that second one I said 1 minus 2 sine squared. That means I've got sines in there. I want sine everywhere if I'm going to get 1 over sine as my final answer. So that's the answer to the question my students often ask, which is how do you know where to get started, what do you know what to do? And it is a little bit of trial and error. It could be sometimes that I'll get a certain way down the proof and then think, oh, no, this isn't the right process, and actually go back and start it again. But with this one, the cos 2x, I would change that to 1 minus 2 sine squared x all over sine x. And the sine 2x, as I say, don't have a choice here, 2 sine x cos x all over cos x. And if we then just look at that before we do anything else, we can see that they cancel. So I'm going to get 1 minus 2 sine squared x over sine x plus 2 sine x. Now, this is a very common place to get to in one of these proofs, and the simplest way I can say it is to turn this into a fraction and then cross multiply, and multiply those together. If you can see it quicker without having to write all that out, then that's absolutely fine. I tend to do it like this because obviously I'm explaining it to students. So if I do that, then I'm going to get 1 minus 2 sine squared x up there, plus 2 sine x multiplied by sine x all over sine x times 1, so all over sine x there. And then this is really nice now. If we tidy that up, 1 minus 2 sine squared plus 2 sine squared, everything drops out. We just end up with 1 over sine x there. Basically, those two cancel. And that is equal to cosec x, which is the right-hand side, equals cosec x equals right-hand side. And so there's a nice, simple, straightforward proof of the first part. Part B then says, hence solve between 0 and pi over 2. The bracket squared equals 6 cot theta minus 4, but the bracket obviously is exactly the same there. Or just check that it is exactly the same thing, but it is here. So it's hence I'm going to be using my first part to do that. So if I'm going to do that for part B then, so they said cos 2 theta over cos theta plus sine 2 theta over cos, sorry, the first one's over sine, give me a second, squared equals 6 cot theta minus 4. Standard Mr. Peters' mistakes of not copying things out properly. Need to focus. Yeah, so that left-hand side then is just cosec. And so cosec squared. The bit in the brackets is cosec, so that's cosec squared theta is equal to 6 cot theta minus 4. And then this is them testing that you know all your identities. So you should know them as well as you possibly can. I really drill it into my students, but even as a minimum, you should know what's connected to what. So, for example, sine squared and cos squared are connected, sec squared and tan squared are connected, and cosec squared and cot squared are connected. So if we know if we remember that, then cosec squared is actually 1 plus cot squared theta is equal to 6 cot theta minus 4. And I would have struggled if it was anything other than that, because now I've got a quadratic in cot, which is probably the simplest way of going from that first line there. So tidy this all up. Cot squared theta, I'm just going to do it all in one go, minus 6 cot theta plus 5 equals 0, just getting everything like that. This is a quadratic. Given that we're, the design of the question, I would always have a go at trying to factorize. It could be that you use a formula, but actually here, no, this does factorize. Cot theta minus 1, cot theta minus 5 equals 0. You can use a formula, it'll slow you down a little bit, but if it means you're going to get the answer right, then no problem with that. So cot theta is equal to 1, or cot theta is equal to 5, and then we don't want cot, do we? We want 1 over cot. 1 over cot is tan, so we're going to say tan theta would be equal to 1, and tan theta would be equal to 1 over 5 then. Again, hopefully no issues with tidying those two bits up. Then just go back and remind ourselves of what the range of values was between 0 and pi over 2 and to 3 sig figs if necessary. Well, if tan theta is equal to 1, inverse tan of that theta is going to be pi over 4, so that's an exact value. But if tan theta is equal to a fifth, inverse tan of that in radians to 3 significant figures gives me those two answers. Solves part B. Let's have a look at part C then. Part C was talking about integrating, wasn't it? So using the result from part A again, because we've got this same thing in here, that's going to be cosec. Can we find the integral between pi over 4 and pi over 6? It's going to be cosec cot in a minute, but let's at least write it out first of all. So we've got the integral between pi over 4 and pi over 6 of cos 2 theta over sine theta. This was the original part again. Sine 2 theta over cos theta. All of that times by cot theta d theta, which is then going to give me the integral of cosec cot. And pretty much as I said with the knowing the identities, even if I don't know what the answer to the integral of cosec cot is, but I do know it's in the formula booklet. So I've learned sec tan. I'm half remembering these things, and then make use of the formula booklet. So I don't need to do anything complicated with that. The first thing I do is go and just check against my standard integrals, and actually, as it comes up, and you go, oh yeah, of course it is. It's minus cosec theta that between pi over 4 and pi over 6. And depending on how much revision you've done, you might just know that straight away, or at least as a minimum, as say, should know that cosec cot is one of the standard integrals there. And then you're just putting cosec, I'm not even going to bother finishing this off in terms of the length of the video here. It's pi over 4 and pi over 6. They are 45 and 30 degrees. You'll get 2 minus root 2 coming out if you take a little bit of time and just put all that in. So, say one extra line maybe, minus cosec pi over 4 minus minus, so plus cosec pi over 6. And then remember, as we said previously, cosec is 1 over sine, so it works out to be, this one's 1 over root 2, and this one's a half, but it's 1 over those, so 1 over that gives me 2 minus root 2. But so you can do that bit for yourself, and just go back and check with the answer, but exact value, so yeah, absolutely perfect. Only worth 2 marks that, so don't take too long over that last part. Hopefully that all makes sense.